OpenJDK. There's been a few changes since last year, so this is kind of an update on how things have been going as a project as a whole. And I'm going to talk a little bit towards the end about the work I've been doing on the new garbage collector, which is ZGC. So roughly, I'll be talking about the release process. This was the major change. And then I'll be talking about what's been going into the various JDK versions since JDK 9. JDK 11 is the next coming release, so I'll speak a bit about that. Looking a little bit forward to JDK 12, and then finally about ZGC. There aren't many people here, so please interject if you have any questions or queries or something to add. So JDK 9, JEP 312, I believe, was introduced, which was a change to the release process. We went from, say, a multi-year cycle for release to a 6-monthly cycle. And what's happened is that that's actually been adhered to. So JDK 9 came out, and then that was followed by JDK 10, and will be followed by JDK 11 over those 6-month periods. A week tomorrow, JDK 11 will be coming out. And that's what I've been working to the past few months. One of the other additions was, there was an announcement that every 3 years there would be a supported release for the next 3 years. And people understood that to mean that JDK 11 would be supported for 3 years from now. What's become apparent is that with Oracle, they're going to be supporting it for 6 months in the open, and then doing paid support from then on. So there's discussions going on just now in the community about how we then support things commercially, support things in the community in terms of a build that would be supported by folks other than Oracle. JDK 11U has been cut, and that's where updates will be going into for the next release and the release after that. And from that point onwards, it's going to be everyone else who's going to be backporting and putting in fixes there. The discussion is that it may be Red Hat that's leading that. JDK 8, everyone's excited about in terms of continuing to support that, because many things will still only require JDK 8 and nothing subsequent to it. So again, Red Hat might be stepping up to take over leading that. You might not be aware, but OpenJDK 7 is still out there and supported by Red Hat, not Oracle. JDK 6 had been supported by Azul, so there is precedence for this. And of course, JDK 12 comes out next March. And as far as Oracle is concerned, that will supersede JDK 11. Can't mention any of this without also mentioning the AdoptOpenJDK project, which has been rising in prominence. People have been, one of the most oft asked questions is, where do I get builds? AdoptOpenJDK has become all the more necessary with these community efforts to actually produce efforts. And there's a lot of people involved in this. On the surface, it looks like a little website, but there are all these companies involved, and Linaro as well is supported, is helping with some hardware. If you speak to Ed, you can talk to him about what Packet is doing for various projects, but one of them is doing builds for AdoptOpenJDK on AR64, which is, I think, going forward is going to be all the more important. Only just this week, Azul announced they were going to be a primary sponsor to this project, so there's some quite influential people getting behind this project. One of the things they're doing is they're not just doing builds. Anyone can do builds, but they are doing the they are doing some additional testing, and they're also doing additional TCK testing, which isn't something we do in Linaro for our engineering releases. What is a TCK? The TCK is a technology compliance kit. Basically, Java is more than just the specifications. To be compliant with Java, you have to pass all of this test suite. This test suite tests the languages, well, the language. It tests the virtual machine behaving properly. It tests the behavior of all the APIs. And when I say all the APIs, I mean all of the APIs, whether it be networking, printing, graphics. It's a large test. Now I'm going to go through what's happened since JDK 9. I said a selection of interesting JEPs. This is my bias. If you're interested in Unicode 10 support, I suggest you look at the list of JEPs for JDK 11. But it's not core things that is of particular interest to ART64, so I'm not listed all of them. So September 2017 is when JDK 9 came out, and this was the last big release of Java. And by big release, I mean list of features. There's 91 JEPs, and these are enhancements to Java. And a lot of them are of particular interest to ART64 because Java 9 was the first release with ART64 as part of the code base. JDK 8 is on its separate branch, or repository, on the OpenJDK infrastructure. Compact strings is something I worked with Bellsoft on. This is where we're taking strings and reducing them down to 8 bits, if that is at all possible, better memory usage. Some things that people are interested in is the string concatenation and invoke dynamic function. I know the ARM team are somewhat interested in that. This fundamentally changes how we deal with strings in the language. I'll skip over that though. Ahead of 10 compilation was introduced in Java 9, and very much at the last minute. This introduced the Graal compiler to compile Java code in advance for x86, 64-bit. There's no ART64 support for that in Java 9 because there was basically a couple of months before the ramp down happened. And the big change that really is the elephant in the room is Jigsaw, the Java module system. And this is where a split happens between pre-Java 9 and Java 9 onwards in terms of software support. I don't know, Ganesh is nodding. Yes. Another thing that's happened is that Sunmisk Unsafe got locked away. Now, there's a long story as to what actually happened during development of Java 9, but in the end, Unsafe became more restricted in terms of access to it. That was loosened up a little bit because it broke everything that used it. But the idea is that with var handles, much of the functionality could be replaced. Perhaps people with middleware experience can speak to how that's been mitigated. And the last final surprise JEP that went in was the 32-bit, 64-bit ARM port, open source from Oracle, which caused lots of confusion and consternation as to what would be supported, because JEP 237 introduced one backend for ART64, and JEP 297 introduced another backend. That's not the end of that story, but I'll continue. Yes, Richard. Well, the module system changed the visibility of some parts of the VM that meant that middleware which used unsafe quite heavily would then be by default not actually working properly. So sun-misc unsafe allows you to do bad things like access memory directly. And so it was always an implementation specific function that unfortunately everyone then used. It's bad, you shouldn't use it. And so the modularity features allowed you to lock that away. I don't know, Ganesh, have you found that you can turn this off easily enough? You don't know? Okay. But there's things like maybe, try to go off the top of my head, but things like Cassandra and whatnot can actually use memory in ways that isn't really typical of Java, which would then mean that they don't work out of the box on Java 9. So there's kind of been a split then in terms of people wanting to stay on Java 8, and then to what degree packaging being brought forward for Java 9.
What was the motivation to unify the 32 and 64 ports?
Pardon?
What was the motivation to unify the 32 and 64 ports?
So that wasn't a unification project. That was a project where Oracle merged in its ARM32, ARM64 port. Now, the ARM64 port that was done in the OpenJDK project was purely ARM64. Oracle started out with a 32-bit commercial VM, and then they added 32-bit support within that code base. So it's unified from the point of view of the one code base generates a different backend depending on what compiler flags you've set. So it's unified from the point of view of that's how it was engineered. So I said JDK 9 was a big release. JDK 10 wasn't a big release. It had 12 JEPs, which is, I'm no mathematician, but 12 is less than 91. So this is playing into the cadence cycle where you're releasing based on time rather than what features are there. And there were a few significant ones. The garbage collector interface is still an ongoing project, but this is where garbage collection tends to be buried quite deeply within the code base. If you're adding a new garbage collector, you have to change the JIT, you have to observe ABI issues and sort of things like that. Adding a new garbage collector is very difficult. So this has been a refactoring job that means that adding a new garbage collector is much more simple and hopefully better quality. Another thing that was added was the experimental Java JIT compiler. So in Java 9, we had the ahead of time compilation with the GRAL compiler. This is adding support for using the GRAL compiler as a JIT compiler instead of AOT. There's an option there we can call the use JVM CI compiler. GRAL doesn't have to be the compiler you use. If you want to write your own one, good luck to you. And so there's been some work done on getting that working. Another cute language feature is the var keyword, which you'll see a lot more in post-JDK 10 work. Basically, if the language can determine what type you're actually assigning to a variable, you can just declare var and it'll work it out for itself. Example Java code, you'll see a lot more of that in future.
Is it like auto in CLM1?
Sorry?
Is it like auto in CLM1?
Yes, very much so. And of course that's going to be replaced by JDK 11 next week. So JDK 10 is going to be dead from then on. In terms of people from the community stepping up to support JDK 11, there's work in progress there. There was queries made about people supporting JDK 10 on for now onwards, but no one was interested, and I'm not terribly surprised. JDK 11, again, not a huge release, actually smaller than JDK 11 in terms of numbers of JEPs, arguably not in terms of size of functionality. There's a number of significant JEPs. There was the Epsilon no op garbage collector, quite possibly the worst named feature ever. It's not a garbage collector. What it does do is you can allocate memory, but you do not free memory. And so it's really fast. But you will run out of memory eventually. There's a couple of intentions behind it. One is you can do benchmarking and you can see the effects of your program without garbage collection. If you're testing different garbage collectors and seeing performance, you can look at the overhead of that garbage collector. Well, this doesn't have overhead because it doesn't do garbage collection. Another one is with sufficiently large heap and a sufficiently short lifespan. If you're just bringing up a function, doing some work and then shutting down, that might be ideal for you. Yeah?
No, so if we are using the no garbage collector, so will safe points all be removed from the JDK code?
Excellent question. I don't believe so, no. The safe points are used for more than just garbage collection. If you're doing things like, what's the word? When you go from, sorry? Yep, you're going to debugging, you'll need safe points. If you're going from, if you're optimizing or de-optimizing and stuff like that, there's lots of reasons for it. Biased locks as well, I guess, will be redone. So I've not looked, but I expect they will still be there. JDK 11 will have the Z garbage collector. I can't actually see that. Which is a new no-pause, well, low-pause garbage collector. It does concurrent copying. I'll talk more about that later. Java Flight Recorder, that does event-based logging with low overhead. That was a commercial feature. And so this was, I think, one of the last steps for the Oracle JDK to be the same as OpenJDK in terms of features. Before it was a paid-for commercial feature, and they're removing that. And there was JEP 315 by our colleagues in Bellsoft, adding some perhaps improved intrinsics. Glad to say that tomorrow Dimitri's talk will be given on that kind of work. And of course, AOT was ported to AR64 by Andrew Haley and co. And so that kind of gives us feature parity with the same features introduced in Java 9. So there's a delay of a couple of releases there. There's also the Java Mission Control tool. That fits into JMX and the Java Flight Recorder. I've not managed to get it working yet, otherwise I'd presented more on that.
You mentioned the AR64 AOT. Is it like a commit inside the JDK 11?
A commit inside JDK 11, yeah. That was introduced on the way to JDK 11.
Okay, it's just not a JEP.
It's not a JEP. Not everything is a JEP that's of significance, and it was quite unusual for those intrinsics to go in as a JEP, actually. Not just an improvement. Not a lot to say about JDK 12 so far. The ramp down begins in December 13th. We'll need to monitor what's likely to go in there. It does get to let me talk about some issues with optional features. There's 3 different ways for putting optional features in OpenJDK. So you can there's 2 preview language features there. These affect what happens with Java-C. So if you do enable preview as an option on Java-C, you can use these features in JDK 11, but they're not regarded as a JDK 11 feature per se. it's used for people to experiment with, and maybe they'll introduce it as a baseline feature in, say, JDK 12 if there's feedback. So it's stuff that's subject to change in the language. There's also experimental features in the hotspot machinery itself. So if you do unlock experimental VM options, you can use things that use ZGC. You have to pass that flag in order for the functionality to become available. There's also, so that's languages. There's VM functionality, and then there's APIs. There's also a means to add APIs that are experimental. They're called incubator APIs, and one of those was the HTTP2 client functionality. It was introduced in JDK 10 as an incubator. That was then accepted properly into the spec for JDK 11. So the actual package changes. JDK incubator vector, ask Ninsheng when that's going to go in. Or maybe not. In development for the future, there's the vector API that I mentioned. Ninsheng gave an excellent talk this week on the work that's been done in ARM for SVE and the vector API. There's a Z garbage collector, which I'm currently working on, and one which I shouldn't put this up because it might provoke more questions, but there's the speculative execution limitation JEP, which might be going in for JDK 11. I think it may be targeted for it, and then perhaps for the intrinsics. So I can't actually see the time. Three minutes, okay. I didn't think I'd have much time to talk about this. So there's the Z garbage collector. So this is, again, an experimental feature that was introduced in JDK 11 on x86, 64. Oracle produced these features for their main platform, which is x86. And this is a concurrent copying garbage collector. What this means is objects are moved as your program is executing, not while the program is stopped. So the idea is to remove as many pieces of work during the pauses and do them concurrently as much as possible. There are other concurrent garbage collectors. There's Shenandoah from Red Hat, which is an OpenJDK on ARC64 too, but not merged. There's Android Arc's concurrent copying collector. And in research, I think there's about 8 or 9 different ones. So it's a well-trodden area. The goals are to have multi-terabyte heaps with 10 millisecond maximum pause time. With some fairy dust as well, that would have no impact on your throughput, but it does. But that trade-off could be well worth what you're doing for your workload. And so we should be aiming for similar goals. As I said, it's more than just moving objects. So marking objects is done concurrently. Copying objects is done concurrently. Handling weak phantom references is done too. And there's some other work that's currently being done on class unloading occurring concurrently. There are some short pauses to do your housework before doing that, but it's region-based. So it's much like G1 in terms of how it looks in some ways. It's single generation, so we don't have an old generation. Everything's considered equal. I mentioned that there. Now, what I'm working on is, when they initially posted this, it was on Solaris Spark. And so the intention is that I'll be doing similar work with the ARC64. The object references themselves are what is marked. Now, this is a little unusual in that most garbage collectors have an off-heap data structure that tracks the marking and so on. But instead, we're actually marking the references themselves. And so the references from one object to another will have some metadata. I'm using the ARC64 top byte ignore functionality to have this metadata. x86 doesn't have this sort of functionality, so instead they're mapping the same memory in multiple places to remove the significance of the bits.
With RT8.5, you don't have to apply ignore anymore because it's used for memory tagging. If you add this use memory tagging extension.
Observe where I put the 4 bits. Observe where I put the 4 bits.
Okay.
So what you're talking about uses 4 bits in the top byte, that's correct. As how well that will work with this, we'll see. As it is, I'm working on this for existing machines. As to whether or not there's an advantage to using it for that, I don't know. I may have to fall back onto multi-mapping like x86. The concern is the TLB pressure. So I'd rather not do that. Incidentally, the memory is mapped, unlike normal heaps, where we have a fixed set of memory. We're allocating 4 terabytes of address space no matter what, and then getting physical allocations therein. I think I'm just about out of time. Currently, it works in interpreter. C1 kind of works. C2 doesn't, because I've not written it yet. Yes. So, I think time's up. But any quick questions before? No? Okay. Well, thank you very much.